Hey, Matt.
Hey, Mike.
Would you like to do a podcast?
I would.
Let's do it. Hello, and welcome to Hacking the Grepson. I am Mike. I am here with Matt, as always.
Hello.
Welcome, Matt. How are you today?
I'm good. Welcome, Mike.
Excellent. Welcome, Matt. So today on Hacking the Grepson, we're going to try a bit of an experiment, something we have never done before, sort of. We are going to try to improv solve a code problem or a code puzzle. And we've done podcast episodes in the past about the advent of code. That's at adventofcode.com, which is an annual series of, there's 25 puzzles. It starts on December 1st and ends on Christmas Day, the 25th. Each day you get 2 puzzles. The puzzles increase in difficulty over time, like each day presumably gets harder, and each day has 2 parts to the puzzle. Usually the first part is easier than the second part. I thought we would try to solve one of these problems that we've never seen before, so we're going to go into the archives of Advent of Code 2019, open up the first problem at the same time, and try to solve it. Does that sound like a good idea to you, Matt, or does that sound like a crazy idea?
Why not both?
Is it a great idea or the greatest idea?
It's just crazy enough to work.
Let's do it. Okay, on 3, we're going to click on day 1, and we've got our code editors out. Do we want to decide on a language that we both write in, or should we just write in whatever we feel like? What do you think?
I mean, I was just going to do TypeScript, which I think you also know, so we could go with that.
I do know that, although I'm a little rusty because I generally do JavaScript, so I might default to JavaScript, but they're so similar that we should have roughly the same solution.
Yes.
Okay, on 3. 1, 2, 3.
Shall I read it out loud?
Yes, please, Matt. Read day 1.
Day 1, the tyranny of the rocket equation. Santa has become stranded at the edge of the solar system while delivering presents to other planets. To accurately calculate his position in space, safely align his warp drive, and return to Earth in time to save Christmas, he needs you to bring him measurements from 50 stars. So that's like the theme of the year 2019's Advent of Code. Collect stars by solving puzzles. 2 puzzles will be made available, blah, blah, blah. That's not relevant to the game, to the question. All right. The elves quickly load you into a spacecraft and prepare to launch. At the first go, no-go poll, every elf is go. Until the fuel counter-upper, they haven't determined the amount of fuel required yet. Fuel required to launch a given module is based on its mass. Specifically, to find the fuel required for a module, take its mass, divide by 3, round down, and subtract 2. And then there's a bunch of examples. I'll read one of them. For example, for a mass of 12, divide by 3 and round down to get 4, then subtract 2 to get 2. And then there's a bunch of others. The fuel counter-upper needs to know the total fuel requirement. To find it, individually calculate the fuel needs for the mass of each module, your puzzle input, then add together all the fuel values. All right, that seems pretty straightforward.
It does. So the final question is, what is the sum of the fuel requirements for all of the modules on your spacecraft?
Yep.
And as always, they say, to begin, get your puzzle input, which is a link to a text file. And so this is the thing they want you to read in some way.
Just a bunch of numbers.
It's just a super long list, maybe 100 numbers or so. Okay, so Matt, what is the first thing that you would do to solve this kind of problem? Like mechanically, what is the first thing you do? I mean, besides opening an editor.
Mechanically, the first thing I would do is code-wise, I assume is what you're talking about.
Yeah.
I would make sure I read all the input into a readable location. Right. In this particular case, it's numbers. I probably wouldn't make any classes or anything. I would just make a list or an array or whatever of the numbers in the thing so that I can iterate over them and do work. You?
Yeah, well, normally what I do on one of these is, because they give you examples, I usually grab the examples. I mean, often it's like in a little text block that you can just copy and paste. This is for list items, so you would actually have to type them or copy and paste out of them and get it to work on that. And then I make the file input thing to pull in the test input, and then I run it. But
That's fair.
they both
Yeah.
they both get to the answer in the end. So
I actually usually do the example as well. I usually copy the real data out and the example data out, but since the example data wasn't in an obvious format this time, it didn't occur to me.
right. So let's see. I think probably the best way to go about this is to write that code, and I suppose we should do any kind of running commentary that makes sense while you're doing it to get at least the example things to work, and then it should obviously work on the test input once you have the file input function
One
working.
would think, yes.
Yeah, so I'm starting off by grabbing the example items they give you, which is 12, 14, 1969, haha, the day that America went to the moon, or the year, and 100,756. I'm not exactly sure what the significance of that number is, but I'm sure it means something.
It might just be big number.
Right. We have like 12, 14, 1969, and big number. I mean, if I'm right in general about how this algorithm works, just for edification, I tried the first day of 2020, which I had never seen before, like a week ago, and the algorithm for that was more complicated than this one, and the second part of it was even more complicated. This actually seems quite a bit simpler than that one. That one, just so you know, required you to take a list of numbers and find the two numbers in that list that, when added, equal a target sum. So you have like 100 numbers in a list, and you need to go through that list and figure out which two numbers, when added together, equal 5,000. And then the second part of it was now go through the same list and find the three numbers that added together equal that sum. It doesn't seem hard, but it actually was something that I was not familiar with and had to kind of do some research to figure out the right way. There was a naive way to do it, which was multiple loops inside. But
That's usually the naive way to do things, and
Yes.
you get your big O of n squared or whatever.
right, yeah. Then there was like hash maps and other various smarter ways of doing it.
All right, so what I've done so far with this,
Yes.
which is nothing, is I have written my little for loop that will read in every line, convert it to a number, and push it into an array of numbers called values right now.
Mm-hmm.
And then, I mean, honestly, this prompt is simple enough where I'm pretty sure I can just now solve the problem and sum up the values. And since something I like to do when I'm doing Advent of Code is I like to try to do things correctly for the language I'm doing it in. So whereas I'm inclined to just do a for loop and iterate over and do the math and sum the value, I think a MapReduce is probably the right way to go about this, or a zip or whatever it's called in TypeScript. So I am going to go research that because that's
Okay.
what I always do.
And while you're researching that, before you research that, can you just explain, for the podcast, like what a MapReduce algorithm is?
Yeah. So when you have a list or an array of objects, three really common methods that you can use to iterate over and do something with that array are map, reduce, and filter. Map runs a function on an item in that array and then returns it. Reduce, if I remember correctly, I always have to think about this one, does an operation and then takes that value, I believe, and gives it to the next one, and you end up with just one number at the end.
Right.
Which is probably what I'll do here. I'll probably do a map to get each individual value that after you divide and round down or whatever it was, and then a reduce to sum them all up. But I think there might also just be a sum operation. So I may do that. And then filter is probably the one I use the most, which is, hey, just give me the stuff in this array that looks like this, that matches some criteria.
Right.
And I use that one pretty often. I never use reduce.
I feel like reduce is one of those things that like I should use in place of the for each, because yeah, like you said, the for each is kind of the for or the for each loop, which is essentially go through a list of things and every time you access one of them, do something to it and maybe save it to a result. Whereas a reduce function or a mapping function it's basically like a more elegant. It's almost like is it syntactic sugar? Is that correct to say that it's like a nicer, more efficient looking way to do something? I don't know if it actually has like a performant. It might actually have a performance benefit.
I think it can. I think when you have a map reduce, it depends on the programming language that you're doing it in, but some of them might basically compile down to a more optimized version. Because when you're doing something like a map or a reduce, I don't think there's necessarily a guarantee that you're doing them in order. There might be, but again, I think that depends on the language. And often you can just consider it like I'm doing a bunch of parallel operations, and now I think reduce has to be in order, but I think map is just do all the things and then it returns them in order afterwards. Right. And then I always have to remember to throw in an await here or there because I always forget that in my functions and TypeScript. And then I'm like, why is everything a promise? Okay, so we are trying to take this value, divide it by 3, and then round down to 4. So we're doing a floor of a division. That seems pretty straightforward.
Now, is that a floor or a round?
If it's always rounding down, it's a floor.
Oh, right, because otherwise, if it's 0.5 or higher, it would go up. Good point. Yeah, just for once again your edification, on the example problems, which I'm sure were chosen specifically to trip someone up, round also works, but on the test input, which is the list of like 100 numbers, I'm sure there are ones where it would not, and thus you would be like scratching your head, wait, why doesn't this work? And that's why you have to reach for the floor.
In most languages, instead of having to do a floor, what you would do is you would just do the division. Like in C or C++, if you do a division, it and it's not a whole number, it automatically rounds down. It automatically does the floor. In Python, you can force the division to be to return, like, so if you have 5 divided by 2, right? If you do it one way, you can get 2.5, but if you do, I think if you do like 5 divided, / 2, then it does a full-on division, and it does 5, and then it just gives you 2. So I think in different languages, this might be easier than others.
All right, so I'm going to let you do the map reduce. I'm going to do the naive way, which is just 2 for loops, because this will be a good way to see. Sorry, I don't even need to do 2. I just need to do 1. To see whether the second part will kill the naive approach, because it will need a better algorithm. Otherwise, it takes too long. I think on the first problem, usually the first couple days of any advent of code, you can do the naive solution, which is not performant, and it doesn't matter because they're not giving you like 10,000 values that chew up all the algorithm processing. But I'm still curious.
So interestingly, I ran with the example, and then I summed up the 4 values in the example. So 2 plus 2 plus 6, 5, 4 plus 3, 3, 5, 8, 3, because that's what you should get. And my answer is off by 8. So that means I have some weird answer or weird problem somewhere in my code. So now is the time when I do my type of debugging.
Print statements?
Print statements.
I always feel just a tiny bit of shame that that's mainly the way I debug, because especially in VS Code, which is not a full-on IDE. I don't know if it had. Well, actually, it probably has debugging. I just never look into it.
Huh. Oh, I see what happened. Okay. Did I miss a part where you're supposed to divide? Where you're supposed to subtract something? Oh, and round down and then subtract. I missed the subtract. That would be why I got the wrong answer originally.
That would be good.
Minus 2. There we go. I have now gotten the example input to work correctly, and I'm trying the full-on input.
Oh, wait. Hold on.
And survey says, ding. So I now have the answer to the first part of the problem.
All right. Well, you should go on ahead to the second one, and I will catch up here.
No, I think I'll wait for you, and
Oh,
then
okay.
we can talk it through together.
All right. Let's see.
So you're doing the double for loop here?
Well, I mean, I'm thinking it should just be the one because
Oh yeah,
basically
it would just be one for loop. There's
Yeah,
no
yeah.
reason to do two.
right. I initially did two, and I'm like, wait, I can just put that in the other loop. So let's see. Okay, so from the example, I get a total fuel of 34,241. Let's see. It needs to know
What's the solution you had?
individual
Three,
calculation.
two. Say the number again that you got.
It was 34,241 for the
Yeah,
example.
that's what I got.
Okay.
I originally had 34,249 because I wasn't subtracting 2 for each one. And since there was 4 answers, I was off by 8.
All right, so that's the example total fuel. Let's see. So we need the file. Let's just be fetch, and let's put this in. All right, so I am putting the example, so the actual test input into a text file, and then I am fetching it.
So I have a feeling that the solution you're coming up with will be easier to expand into whatever part 2 is going to be.
Well, I guess we will see.
Also, my solution absolutely could be simplified because I have to read one number in at a time from the input. While I'm doing that, I could just do the map and the reduce inside of my initial for loop, and that would actually be the most efficient way of doing this. But I generally like to, with these, because I like to solve them a certain way. I like to read my input in, get it into a structure, and then operate on it.
Right.
Even though it's slightly less efficient that way.
Yes.
I mean, overall, I'm still O of N on this, even though I'm probably ultimately going through this. I'm probably going through the array 3 times as with my input, my map, and my reduce. Yeah, that's 3 times, but still big O of N. I'm curious. When you write this code, do you read from a file or do you pipe in from standard in?
I know we've talked about this before, and I like to have the input saved, so I always read it in from a file.
I also save it to a file.
You
but
do both.
I always read in from standard in.
Okay.
I think that's just the Unix sysadmin in me, right? Like I like all my functions to be able to just chain together through a pipe, or all my executables.
I am forgetting how to do a simple fetch, like async fetch thing. So instead, I'm going to just put them into...
Oh, were you literally going to fetch it from the
Yeah.
website as opposed
No,
to
no,
just
no, no,
having it
no, not
local?
from the website, just from a saved file. Like fetch
Oh,
the
can't you just...
one.txt. I mean, that's how I did it in TypeScript.
Isn't it file.read?
No, the way now, I mean, in the past few years in JavaScript, I mean, TypeScript may have their own like wrapper around it, but it's just the fetch API. So it's just like fetch file, and then it returns a
I
promise.
do not do it. I have not done that before.
Oh, yeah, you should look into it because that's kind of like the way to do, especially when you're. I mean, it's probably like a web dev thing where everything that you're, all remote resources that you're trying to get tend to be, things that you don't know whether they're available or not. So you always have to have a promise so you can check to see whether it's actually come through or not, and have like error checking in case it doesn't.
I just do what I just pasted in there, which is I use the FS package, and then I do read file sync from a local file, and then I'm done.
Yep. I mean that's probably for a local file. That's the way that people do it. But the fetch works for local files too. Like on Gem Warrior on the web, I have a little avatar feature in the bottom right that changes depending on some of the actions. Like if you're sitting or sleeping or standing, the text. It's basically a little ASCII picture, and all that is a bunch of ASCII text in various text files, and it just fetches the appropriate text file. I even have it on a delayed loop because your avatar blinks. So every few seconds it grabs the blink frame and then goes back to the normal frame.
Huh.
So that was kind of fun, and that's all using the Fetch API.
And I only use Fetch for doing. I don't even use it. I mean, I typically only use Fetch if I'm grabbing a file off the web somewhere. And even then, I don't like the Fetch package. I usually use a different one. Although I have yet to find a good HTTP package in JavaScript or TypeScript. I like requests in Python, which if you it says I think it's like HTTP for humans or something like that, and it simplifies so much of the process. Most of the things that let you read a file or download a file have a bunch of they basically operate in in advanced mode as opposed to a wizard mode, to put it simply. And that, in my opinion, is overkill for most setups. Most of the time, you just want to read a file and have text. The end.
So for the test input, I got 340. Oh wait, no, 3,405,721. Is that what you got?
Oh, that is not the answer I have. No.
Oh,
I have 3,373,568.
okay. Let me double check my test input.
But it worked on your example input. You got 34241 for the example, and then it's the input one that you got the slightly off one.
Yes.
Interesting.
It is. Okay, so let me just double check my stuff here. Okay, so
Well, I think part of your problem might be that your inputs are missing some numbers.
they are.
Oh, wait, we get different numbers. Never mind. I
Oh,
always
indeed.
forget that.
Yes. Let me look at the
I'm
first.
like, no, you're missing things.
Yeah, let me look at the first one and the last one. No, that's it. There should be. Looks about exactly 100 inputs.
Well, wait, hold on. If you and I have different inputs, that means our outputs would be different.
Oh.
So this might be the right answer.
Oh my gosh, yeah. All right, let me put it into the website. The website is the arbiter of truth here, not you.
Correct.
Yay! Okay, we forgot how Advent of Code works. Okay.
We're dumb. Yay.
Okay, so yeah, so just to wrap up, or not wrap up, just to clarify what happened there. Matt and I took different approaches. He used a map reduce function, which is
Technically two functions.
two functions. Oh
I
yeah,
mapped and then I reduced.
yes. So the mapping is to essentially like, hey, do something over every element of this collection, and then what you're doing to them is a reduce function, and then you give it some kind of function which essentially takes the previous one, does something to the next one, so you only get one number at the end rather than another array or a collection or object or whatever that's equal to the same number of elements as your original one, just manipulated.
Slight clarification on that.
Yes.
The reduce is after the map. So the map
Yes.
runs and
Oh, I see.
And I think it might actually treat it as a stream and do it all in kind of one go. But that's hidden from me. But effectively a map would give me the way I have my map set up. It would give me back an array of all of the fuel required, and then the reduce is just doing the sum.
Right. Right. Okay.
This would actually be really easy to do in Excel. That's the problems that I find the most fun in the advent of code. I've realized almost always boil down to you could just do that in Excel.
I mean, I'm sure we're not the first people to have the idea of doing Advent of Code in Excel.
I solved at least one problem one of the years by hand, and I solved at least one with a spreadsheet.
Yeah.
So.
I mean, you could probably do all of Advent of Code by hand. The issue is that the number of inputs increases to such a untenable amount eventually that it just becomes, that's what computers are for.
Yep.
Okay, so since you got to read part 1, we both have a gold star in 2019. Now there is a part 2 that is open. I will read that and then we will talk about our approach.
Sounds good.
So part 2, during the so we both know now how much fuel we need. During the second go no go poll, the elf in charge of the rocket equation double checker stops the launch sequence. Apparently, you forgot to include additional fuel for the fuel you just added. Fuel itself requires fuel just like a module. Take its mass, divide by 3, round down, and subtract 2. This is getting a little recursive here. However, that fuel also requires fuel, and that fuel requires fuel, and so on, and so on, and so on. I'm reminded of that Wayne's World scene where he's talking to his girlfriend and telling about like, oh yeah, you should tell a friend about this thing, and they should tell two friends, and they should tell two friends, and the image keeps,
Which is itself a reference to an old commercial, if I remember correctly.
oh, I'm sure, yes, but the screen keeps dividing and dividing and dividing. Anyway, any mass that would require negative fuel should instead be treated as if it requires 0 fuel. The remaining mass, that's helpful. The remaining mass, if any, is instead handled by wishing really hard, and that is highlighted, which has no mass and is outside the scope of this calculation. So, for each module mass, calculate its fuel and add it to the total. Then treat the fuel amount you just calculated as the input mass and repeat the process, continuing until a fuel requirement is 0 or negative. For example, a module of mass 14 requires 2 fuel. This fuel requires no further fuel because 2 divided by 3 and rounded down is 0, which would call for a negative fuel. So the total fuel required is still just 2. At first, a module of mass 1969 requires 654 fuel. Then this fuel requires 216 more fuel, blah, 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 blah. We don't need to read all the numbers. I think we get the idea. What is the sum of the fuel requirements for all of the modules on your spacecraft when also taking into account the mass of the added fuel? Okay, so
the first thing I did, as you were reading this, is I know the place where I'm going to struggle with this the most is adding a recursion, because I agree, this looks like it'll be recursive, into my fuel calculation in the way that I had it before.
Yes.
It would have been frustrating.
Yes.
So the first thing I did is I took that math.floor n over 3 minus 2, and I broke it out into its own function called calculate fuel. And then in my map, I'm just calling that. And then I've rerun my example, and I get the right answer. So now I just have to add the recursion, and I will be done, hopefully. What's your approach?
Wow. Okay. So, I mean, it seems, yeah, I feel like my approach would be pretty similar. I mean, I'm not using the map and the reduce, but essentially my very naive for each loop essentially needs to be a function so that it can call itself, but only if the result of it is, does it say not negative? Well, and I guess you can't divide 0 by, well, no, you can divide 0 by 3, but then you would get a negative number anyway, so I guess it has to be positive for you to choose to recurse again?
Yes. I think if it's 0 or below, you just return 0, and otherwise you would add it.
Well, no, because even if you did 1 divided by 3 to the floor is 0, minus 2 is negative. So
Right.
you really need to do...
You need 0 fuel.
You need something... You need an input mass, or you need an input fuel of something that, when divided by 3 and having 2 taken away from it, is positive. Otherwise, it's pointless.
So I'm just doing the math every time. I'm getting what the floor would be, and then depending on the result,
Yes.
I'm either throwing it out or I'm adding it to the total cost of my fuel.
Okay, and I was just thinking, like, even one step higher than that, if the input divided by 3 is not positive, then skip it. But at this rate, it might be overthinking a little bit. But in general, I think we have the same idea, of which this needs to be a function that can be called, that can call itself, but only if the input is of a certain condition. Otherwise, skip it, and then otherwise we should get the answer. So let's take time to do that, and then we will come back. I am terrible at making things into functions because I always just like, well, it's a for loop and it has to do a thing. But this problem is perfect because it's like, okay, no, you can't easily do that. Actually, I'm not sure you can do that at all if it's not a function that can then be called, that can call itself. Because otherwise, then I would be writing the same loop inside of itself, inside of itself, inside of itself, and that would be maddening. That would be madness.
Space madness. Okay, I think I have an answer that will work.
You are faster than me, but that's okay.
I am very good at recursive functions. It's
Yes.
my jam. Survey says. Yep. A win.
All right, excellent job. You will now wait for me, who is slower.
So for our listeners, a recursive function is one that calls itself. So let's say you, for example, wanted to, I don't know, get the number of times you could divide by two without hitting zero or less than one. You would just have a function called like make cut in half, and as long as your value was greater than one that you were passing in, you would basically return cut in half of the input value divided by two. So you always have to have a base condition in a recursive function that basically says, okay, get out of this recursive function. Otherwise, you end up in an infinite loop and you never finish reducing.
And none of us have ever done that before.
Relatively straightforward to do this without recursion, but I wouldn't. Like, I think you could switch this over to a for loop with some extra input. Like, a for loop with a while loop inside of it, I think would do the job, but I like recursion better.
That's true, yes. Yeah, so I am definitely weaker on this kind of stuff. I don't write recursive functions on the web for anything because that's just, there's, I don't write algorithms on the web very much. And so this is kind of like, okay, wait, this is logic. How do I do this logically? I'm not trying to, update a web page or fill in a form or something. So I'm just going to talk through what I'm thinking and you tell me whether this makes sense. So essentially, my function that I'm calling recursively takes an input from our test input, so a number, and it calculates the fuel from that. So really, this is just so I can get the words right. It takes a mass. Actually, it could be a fuel. I'm going to keep it as input because it could be mass or fuel. It could be the initial mass.
I just called it N.
Or N. Okay, I'm going to call it input. I'm just so you know. I mean, we're learning things about each other. I'm very easily not persuaded, but influenced by what the problem calls the things. So if they call it an input, I'm more likely to call it an input. Anyway, so it takes an input, which is a number, which could be the initial mass, or it could be a fuel that you're recursively calling, and it calculates a new fuel, which is that input divided by 3 floored minus 2.
Yep.
And then we do our check. And if the fuel is still above 0, so if it's positive, then we instead call this function on that fuel again. And I add
Yes,
it.
but you have to make sure you don't lose your original fuel.
Oh, right. So that should be the total fuel, right? Or should that be its own fuel variable? Like an
It depends on how you're calculating it. I use the same variable throughout,
let's see.
but I think there's different ways of doing it.
All right, let's just make it. We'll just make an init fuel, and that's what I'm adding to. So it starts at 0, and it adds the result of calling itself again, which should eventually, it will keep making a smaller number that will eventually not be positive anymore. And if it passes that, then instead it just returns what is in this ongoing variable that's being added to.
I'm very tempted to turn this into an interview question. This is a good interview question for me. It's relatively quick. There's several ways of solving it,
Yeah.
and it leans on some things that people don't do all the time.
So I've got the function. So we've got the example inputs and the test inputs. And the test inputs are 12, 14, 1969, 100, 756. So if I run that on example inputs for each, right. So what did you get for the example total fuel answer?
The one I pasted in there, 51,316. That's including the 12 that they didn't put in there because I didn't change my input array.
Okay. So I can't share my screen, so I'm just going to talk through this again. Okay, so I went over. So my processing function takes the input and it calculates the fuel. If the fuel is positive still, then that means it needs to run itself again. And I have a running total of wait, hold on a second. Let me read that. I need to read this question again because I think I'm mixing up the individual fuels and the total fuels.
Yeah, the individual fuels where you do the recursion based on what it says. I initially thought we would take the initial answer and then flow it back through this until it got down to 0, but that isn't what the prompt says.
Okay, so the initial fuel, so every input that you get, you're trying to figure out the fuel. The difference here is that also requires the recursive fuel that you're figuring out if the number is big enough. Okay, so the function is the same algorithm, which is the input divided by 3 math floor minus 2, and that gives you the fuel. It's just that if that's positive, then you need to add the fuel of running that on that number again to itself.
Yeah.
So if
Right. And then if that's still too big, you have to do it again and again and again until it gets down to 0.
Okay, so
or less.
right. So in the end, this function will return a single number, which is the fuel needed for that mass. Right. So I still need to run. Right. Okay. I still need to run this on each of the inputs, and that still needs to go into a total fuel. It's just that it's running itself. Okay. Right. And then otherwise, it returns the fuel. Okay. I need to make this fuel be outside the function. That was the dumb part.
I'm very curious to see what our calculate fuel functions look like in comparison to each other.
Okay. So right, if it's at so it starts at 0. Oh, okay. Right. I almost think I need to do this for the example, the original thing, because once I moved it out to a function, I think I have confused myself.
That's why the first thing I did is I broke it out into a function,
was smart.
keeping the old value, tested that to make sure I didn't screw something up, and then I added the recursion.
Right.
Because I don't trust myself.
Yeah, and I'm going to do that first because I'm definitely another good thing to take away from this, at least for me, is that I mean, even when I'm doing web dev, if I have like a huge problem that's complicated and uses a lot of different parts, I find that if I take like what is the core issue that I'm working on and break that out into its own like super simple test version of it without all the cruft. Usually I'm trying to do something within a huge website which has a bunch of other moving parts, and those can be distracting or they take a long time to wait for or something, and I just want to figure out the algorithm for the thing I'm doing. I have to move it into its own little test thing, and that's what I should have been doing here.
That makes sense.
Yeah.
I actually work very similarly. I tend to drop into I really like interactive programming languages like Python and, I mean, honestly, TypeScript, anything that has an interpreter. I tend to just drop into those and start screwing around with stuff directly so I can test out that's what I did with this when I was like, how is it math.floor? And like, do I just do a single division sign? Like,
Right.
I went into TS Node directly, played around with it. And I was like, okay, I like that. And then I put it into my code.
Okay, so the one thing I have a question now then is that when I move it into a function, this function has the recursive part in it. Yeah. But for the example inputs, for part 1 of this problem, I don't want that. So is there a way to make this function work for both of them easily?
You could add a Boolean to it that took in like, should I recurse and pass and send that appropriately? And then that would go into your base case, I guess, basically. Is
Right. If it's positive and should recurse, do it. Otherwise, skip it. Okay. So this way, when I do the processing of it, it's right. It's gonna take the input, and it's gonna take a false. So it's always going to just return the first thing and not recursively run it again. Right. Okay. So to go back to the simpler example, the example inputs, which are just 4, it takes an input, which is for the first one is 12. It figures out the fuel, which is our function, and because it's not recursing, it just returns the first thing it gets, and it adds that to a running total of fuel, and then the answer is whatever that total fuel is at the end. Mm-hmm. Okay, right. I was putting it into another for loop, which doesn't make any sense now that I think about it. So, and it cannot find total fuel because I didn't initialize it, but now I did. Okay, so now I still get the 34,241. Okay, so now if we instead send it the test inputs instead of the example inputs, we make sure that total fuel is back to 0. We don't need that variable. And we don't need that variable. We don't need that. And then it should be the same thing. It's just we do recurse this time. So test inputs, not example inputs. And yes, we do want to recurse. And now I print that out to 0. Okay, so now if I run that, the oh, not a number. That's great.
You're dividing by 0.
I am probably... Well, but there's nowhere where I divide by 0. I'm always dividing by 3.
Paste your calculate fuel function in.
Okay.
Or whatever it's called. Let me see if I see anything obviously wrong with it.
Okay.
I have mine ready to go and paste in, but I'm waiting till you have a solution before I do that.
Sure.
Proc input.
Yeah, it's a terrible name.
If fuel is greater than 0 and I
Changing
should
it to get
reverse,
fuel.
Then...
Because that's proc input is seriously gauche, dude.
You're not returning. In the case of your if statement, where it's if fuel is greater than 0 and should recurse, then you need to return.
Oh, return.
Fuel plus proc input. Or you can do what you did and then return fuel. I think actually what you want to do is just get rid of that else statement and just make it return fuel. So if it's greater than 0 and you should recurse, add the next level down. And you probably want to pass in should recurse there as well to your function.
Oh,
so that that level also will recurse.
Good call.
And then you can get rid of the actual else, but keep the return fuel, and that should work.
Oh, I see what you mean. Yes. Okay. That makes sense. Okay. Now let's try it. Okay.
Because I almost wrote my code that way.
Yes.
And then
Now I get I get 5,105,597.
I do see a potential problem.
Oh, is that not what you got on the? Oh wait, no. We have different test inputs. So
no. But on the example input, you should still be getting the same thing.
Let's try it.
Oh,
I do get the same thing on the example input. Yes.
Actually, you know what? In your else statement, I think you need a third condition. You need the situation where fuel is less than 0. That needs to return 0. Right now, that's going to return a negative number. Right? If fuel comes out as being negative, then you're going to return that negative number, and you don't want to do that. You want to return 0.
Okay, so if fuel is negative,
you could make it you could just return max 0 fuel, or whatever the JavaScript equivalent of max is.
Well, let's just try. I'll just put in if it's less than 0, return 0, and see what it does. That did change my total fuel. Let's see if it's right. Although I don't have a case for if it's 0.
0 will just return 0. So that's fine.
Oh, yes, indeed. Okay. So let's put it in and see if I got it right. Huzzah.
Huzzah. That's what mine looks like, which is very similar.
If value is less than or equal to 0, return 0. Otherwise, return... Yes, it does look very similar. Yes.
Yeah.
Wait, so
because if you're going to do it recursive, it's basically going to be that.
So does your function work with the examples?
Yep.
And it works. So if the value would not be less than or equal to 0, so it just returns the value. But you're recursing, aren't you?
But the next recursion down is going to return 0.
Oh, I see. Okay. So they both recurse. It's just that the example ones would just recurse to 0 immediately and stop.
Well, the 12 and the 14 would. The other ones wouldn't. It doesn't work. I don't have a way of going back to the initial fuel calculation in this. I changed the fuel calculation to include recursion. I would have to add that Boolean like you do.
I see.
Should recurse otherwise.
Okay.
But it works for the examples they show in part 2. I get the same answers.
Right. Okay. Well, we did it, Matt.
Yay! Good job. It only took us an hour.
Well, it took you less time, but we did get it, and the result of this was pretty much what I thought, which was you are quite good at algorithms, and I am very weak at algorithms, so it takes me a little bit longer to write this kind of stuff because, yeah, when you spend 20 plus years in web dev, you don't write this kind of stuff. I've written a lot of JavaScript, but it's more event driven. It's like if an input happens on a web page, do a thing, and not count up numbers. Like you said, this could be done in Excel. This is like an Excel problem.
Yeah. It would actually be harder to do the second part in Excel because you would have to find a way. I don't know how you would do recursion in Excel. But even then, like it would be a for loop, maybe. But yeah, there would have to be something. And then there's probably a more efficient way to do all this. Like you could store, since we're doing a double for loop, if we really wanted to be clever and optimize for time,
Hmm.
we could like if we wanted to optimize for time and not space, then what we could do is we could store the like once we got a fuel calculation for a given number, we could store, oh, okay, if the input is 42, then the total fuel required is going to be this. And then anytime we hit a 42 in our recursion, we could look that up in the map
Hmm.
and not have to continue the recursion. So we could optimize somewhat, but this is not a problem that needs optimization.
Yeah, and you also mentioned like another way to do this would be a while loop because
Yeah.
the function that we're recursing is one line. Basically, you that could just be in a while loop, like just keep adding it up until
Yeah.
you get 0 or something.
Yeah, some recursive functions don't do that easily, but this is using tail recursion, where at least in mine, where at the very end is where I call my next. I call the function again at the end,
Hmm.
so it's value plus calculate fuel.
Yeah.
That whenever you see a tail recursion like that, you can almost always replace that with a while loop or a for loop or
Ah,
something.
I have not heard of tail recursion before. What is there another named recursion like that?
Not that I know of. I just know tail recursion. Tail recursion is where the last thing you do in your function is return the function with your new input,
Right.
basically.
Okay. Okay. Cool. Well, we did it. We solved Advent of Code 2019 live.
Huzzah.
Yeah, was that fun? Would you want to do that again?
Yeah, that was fun. I enjoy solving problems, and I like seeing how we solve each other's problems.
Yes.
Or solve problems differently.
Yeah.
I do think we should figure out some sort of shared coding experience so we can both be coding and watch the other person.
Yes.
I think that would be interesting, but I don't know how to do that.
Yeah. That. Well, we'll figure out that technology another time. But for now, you just get you get this, and I think it still worked. But yeah. Yeah. So anyway, I think that's our episode today on improving of code, and we if you enjoyed this episode, we have other episodes about the advent of code, which is that annual programming challenge thing that I mentioned. We did it in 2022, and we did several episodes about it back in December of 2022, so look those up at hackingthegrepson.com. We're still on Twitter/X for now. I don't know if that will last forever, because I basically use that to just post the show and nothing else. But you can check that for, or just add us in your podcatcher, and we'll show up every 2 weeks. We have a new episode, and until then, we now return you to your regularly scheduled lives already in progress.